Still there is issue. Can you hear me now? Okay. I guess everyone can hear me. So I will start the class now. Then. Okay. Thank you. So sorry for the delay. We'll start the session now. So this is our fourth TA session on this course, maintenance and repair of concrete structure. So as we have decided, we will first go to the outline of the whatever you have studied for throughout the week, and then we will go to the some question and answer section. If any point you feel that I am not audible, just put a message or just speak it out. Okay. So in week 4, you might have completed this audio not clear. Wait a minute. Now it's clear. Okay. So first you might have completed the module on deterioration method, and there you might have studied about the fire attack, abrasion and erosion, and then you might have studied about the next module, and where you have studied about the service and exposure condition, visual inspection, testing on concrete at site and in laboratory. So the first thing you might have studied about is the fire attack. So the different mechanism of fire attack is when there is a fire, the moisture inside the concrete will tend to go out of the concrete, and because of that there is a point inside the concrete where we have aggregates more. There a moisture clog will be forming. Because of this moisture clog, more the water will try to seep out through the concrete, more this moisture clog will be the stronger one, and this moisture clog will create stress in the concrete and lead to the spalling of the concrete. Right. Next is the how we can prevent this fire attack. We can use we can use some porous aggregates so that they prevent this moisture to form this clogging. All the moisture will be stored inside these aggregates. Secondly, we can use some plastic fibers. So whenever there is an fire attack, these fibers they will melt themselves and create a pores inside the concrete. So these pores will help to store the water from the inside concrete and prevent it from causing the clogging of the concrete. Next is how we can identify the type of damage due to the fire attack. If we have more the reddish color of the concrete, more we can say the iron content is more in that thing. So more the iron content, more the reddish will be the concrete aggregate, and more iron content and less temperature. At less temperature itself, if we have reddish thing, then we can say it's due to the iron content. Next, you might have studied about the abrasion and erosion in concrete. So how abrasion is taking place is mostly, firstly the top plate surface of the concrete will be removed, and slowly the aggregates, more the loading will be there, more the abrasion is there, the aggregate will start coming out, and then the complete surface of the concrete will be removed. What are the main factors which are influencing abrasion are compressive strength of concrete. More the compressive strength, lesser is the loss, and second is the water cement ratio. So as you can see here, more is the water cement ratio, more is the abrasion loss. Less water cement ratio means more compact our concrete is, and less is the loss percentage. And other thing is different type of aggregates. So type of aggregates will also affect the percentage loss of by the abrasion process. So next is the erosion. So what is the difference between abrasion and erosion? Can anybody tell? So the main difference between abrasion and erosion is that in abrasion the complete layer is the removed, and erosion is because of the impact. Impact will cause this surface, concrete surface, to be removed, and due to mainly because of the pressure of water or aggregate something. So here we have seen two mechanism of erosion. This is because of abrasion, and this is because of cavitation. So cavitation is mostly caused because of the surface roughness. As you can see, if the surface is not plain, there are undulation, or there is different sizes of the beams, or aggregate is exposed, or any other causes uneven surfaces. This type of surfaces can cause more erosion. So how this erosion is normally protected, especially this type of defect we will see in the concrete structure which are under the water, like spillways, dams, weirs. In these type of structure mostly we will see damages due to erosion. So what we will do, we are creating a aerator, and this aerator will remove the air from suck the air throughout from that point, and will prevent the erosion from the surface. So next thing what you might have studied in this week is the condition assessment. So first thing about condition assessment, which factor affect the condition assessment is service and exposure condition, like cold and hot weather, different type of temperature will affect the uh, concrete. Next, moisture, what how much moisture is there inside or nearby areas of the concrete. Different type of chemicals which are added to the concrete, as well as concrete which is exposed to different type of chemicals. Mainly it happened in any industrial buildings are mostly there. And last exposure condition is the loading condition. How much load our building or our structure is facing will affect our the condition of the structure. So different typical steps of condition assessment is firstly visual inspection. So whenever you go on a site, how you will see how you will inspect that structure is, firstly we will do the visual inspection. We will click photos of all the different type of damages you can see. So you will be seeing cracking or delaminations mostly. Second step is review of the engineering data. All the history of that structure need to be studied, mainly their construction period, and how much repair have already been done, and what all had done in the previous uh, thing. And next is the condition survey. Using some NDT test method, we will do the condition assessment. Here you can see it's doing hammer test. You might have studied about this thing, right? And last step in condition assessment is final evaluation and some recommendation. So final evaluation included the lab tests. So we will go for the laboratory testing. So different type of laboratory testing which we are doing for condition assessment are: when a four-prop resistivity test, we will check the resistivity of concrete. More the resistivity, we'll say better is our concrete. So because we say concrete is an inductive material, so its resistivity should be high. If the resistivity is high, then we can say our concrete is of good quality. Next is the oxygen permeability index. How much our concrete is resisting the permeability of the oxygen throughout the surface. So this is the setup of oxygen permeability index. Next test is the carbonation test. So we will spray phenolphthalein over the surface of the concrete, and we will check how much is the carbonation depth. So carbonation, we all have already studied the because of ingress of carbon dioxide, it reacts with hydroxide and form carbonates. So carbonation depth, it's this depth should not reach to our steel surface. We have to make sure that. Next test is the water solubility test. So how much water will seep through the concrete from the bottom, that is the water solubility test. And next is water permeability test. How much water is permeable throughout the concrete. Difference between these two type of tests is, water permeability test is we are checking how much water goes inside the concrete because of gravity from the top surface, and in solubility test is we are checking how much water is seeping through the concrete from the bottom, like how much water is getting into the concrete against gravity. Okay, that is the main difference between these two type of tests. Next is rapid chloride penetration test. So we will have a cell, in one side we will fill NaCl and one side we will fill NaOH, and we'll apply the current and see how much chlorides are seeping through the concrete. Other test which we are doing in laboratory are rapid chloride migration test. This is a almost similar test as RCPT test, that is penetration test. This is migration test. So here the setup will be different, but the solution we are using are the same, NaOH and NaCl. Other test which we are doing in laboratory is we are taking a core from the site and we will divide it into powder and check the chloride threshold of the value, how much chloride is present in the concrete at different depths. So that is a chloride content test. Other tests are the core test which we are mechanical test. These all were the durability tests. So mechanical test, we are doing three type of mechanical tests: split tensile test, flexure test and compressive strength test. So this is what you might have studied in this week. So anybody have any doubt in these things first, can tell. Any doubt in these things? If not, then we will go to the questions for this week. Guys, can you hear me? Okay. Okay, if there is no doubt, then we will start with our questionnaire session for today. So the first question is, what are the major factors influencing abrasion in concrete? I think we have already talked to in the previous slides. Type of aggregates, water content, water cement ratio, curing, compressive strength of concrete. What do you think will be the answer? Okay. ACT. Okay. So
So
I think along with the aggregates, water content, compressive strength, curing will also affect, no? Because curing is indirectly affecting the compressive strength. So answer will be all of the above. I'm sorry guys, I am not able to hear you properly. So you just type the answer in chat box for now. Okay. We'll go to next question.
I think answer B would be the answer. Yeah? B.
Okay, then we will go to the next question. At elevated temperature, say greater than 100 degrees Celsius, the thermal conductivity of concrete increases and then attain a steady state. Is it true or false? Temperature more than 100 degrees. Not audible. Now am I audible? Uh, okay. Still not audible. When audible, okay. So when we are increasing our temperature, how is thermal conductivity? Am I audible or not? Audible. Okay. So with increasing temperature, our thermal conductivity, as you can see, thermal conductivity is inversely proportional to the temperature, right? So with increasing temperature, conductivity will decrease. It won't increase, right? Is it clear to everyone? Match the columns. So column A have different type of deterioration mechanism, and column B will tell about the different type of aggregates and main factors influencing that type of damage. So what do you think is the reason of abrasion? Loss of service. Next is highway subjected to heavy traffic. What can be the reason for deterioration? Loss of surface texture is cavitation, localized damage. Okay, right. Cavitation, localized. Okay. So cavitation, you are telling localized damage as well as surface texture.
Yes, highway subjected to heavy abrasion gives loss of surface texture.
Vision and spillways. First, abrasion. Abrasion is what abrasion is causing mainly loss of surface texture. Okay, so you are telling erosion causes loss of surface texture. Erosion and abrasion have main difference that with abrasion the complete surface will be removed. With erosion, only that point where the pressure is applied, that point will be removed. So it won't cause complete surface texture removal. Okay, is everyone satisfied with the answers? So abrasion, as we have seen from those diagrams, there will be a loss of complete surface texture. We have seen that at one point aggregates will be on the surface, so that then aggregates is also removed. So that's why we are telling abrasion causes loss of surface texture. Then second is highway subjected to heavy loading. So whenever there is heavy loading, there we are using that is, if there is a loss that at that point, that means the aggregates which are used are the granitic aggregates. And next is the spillway subjected to highly abrasive wave. If there is a spillway and we have highly abrasive wave, it is said that they might be the reason of loss might be the because of use of wrong type of aggregates, mainly sandstone aggregates. Next is the erosion. So erosion normally causes uniform damage. Either the complete surface is removed, or there is actually erosion can be localized damage as well, I think, because as we have read before, erosion will cause two type of damage. Either it will be abrasion or cavitation plus abrasion. So in this case we can say that erosion is causing uniform damage as well as localized damage, so both option will be correct in this case. And last is the cavitation. So we will continue also. Fine. So next question, we'll go to the next question then. In a UPV test conducted on a bridge pier, the the velocity pulse detected in the vicinity of reinforcing steel bars varied significantly from the velocity of the pulse through the plain concrete of the same composition. What can be the reason for this thing?
I think is it A?
1.2 to 1.9 times the velocity of pulse in plain concrete. Okay. Anybody else who want to guess the answer? Steel, plain concrete times the velocity of pulse in steel. Okay, that is completely opposite than A. Okay, then we will see. Go to the answer for this question. Accepted answer is A only. So whoever was saying A are right. The velocity of pulse in steel is more than that of the concrete. So if the velocity of steel is more than that of concrete, then only we will tell that the pulse detected varies significantly. Okay. Go to the next question then. So again there is a match of the following. We have different type of test, and then we have different type of factors which are there in this test. So what exactly the test is checking? Sorptivity test, compressive strength test, chloride threshold, oxygen permeability, Venner four-prop, and corrosion current density test. These six tests, and what are the reason? Okay, first is sorptivity test. What do you think is the sorptivity testing?
For suction properties.
What can be the solution for compressive strength test? Okay, chloride threshold test. What exactly? A2, sorptivity is due to the capillary section. B is 3, compressive strength is due to the B is 3. Compressive strength, check the flexure strength of beam. Okay. Chloride threshold is for the propagation phase. Okay. D5, oxygen permeability sensitive to high performance concrete. And E, when a problem, tell about the initiation stage. Sorry. When a probe is sensitive to coatings on the concrete, right? And corrosion current density, tell about the initiation phase. Okay. Anybody have any other guesses? Everyone is saying B. Let's check the answer then. Answer is B only. So you are right. Sorptivity test with the capillary section, and compressive strength is related to flexure strength of beam. You know the criteria in flexure and compressive strength. How much should be?
Compressive strength of concrete, madam.
How it's related to compressive strength? It should be minimum 10% of the compressive strength test. Compressive strength of the concrete. So that is the main relation between compressive and flexure strength of the concrete. Okay. Permeability of concrete influences the rate of corrosion. Do you think it's true or false? True. Yes. So how permeability influences the rate of corrosion? More the permeability, more will be the increase of chlorides, and more will be the chances of corrosion. And that's how permeability will influence the rate of corrosion. Okay. This is a very simple question. We'll go to the next question. Okay, this is an application based question. You are asked to design a 3-story commercial building in a high fire prone zone. Select the strategy you would adopt. Will you use a high strength concrete with finely ground and controlled burnt rice edge? Or you will use the granitic aggregates? Or the coating of the surface of concrete to prevent the transfer of heat into the concrete? Or you will use plastic fiber in the concrete?
Operation of plastic fibers in the concrete mix.
D. Okay. O C and D. A C and D. Okay. A. We want to use high strength concrete because we want our water to move out of the concrete without causing any clogging. So we won't use any finely ground material in this case. We want it to be a little bit permeable so that all the moisture can go out of the concrete. Okay. So this won't be correct. C and D is correct. Correct. So both C and D are the correct option. Uh, hey Mayu, I hope you understood why A is not correct, right? An infrared thermographic inspection was carried out on a concrete pavement of 10-kilometer length using a high resolution thermographic camera mounted on a moving vehicle. Figure 1 shows a photograph of the pavement being inspected. I'll show you the figure. This is the figure of the pavement. Okay. The note is saying the thermographic image records the maximum temperature on the concrete surface in red color. For this condition, which of the following observation can be correct? So this is a pavement, 10-kilometer long pavement, and based on these observation, this red part will tell about the temperature. What do you think is the correct observation? C will be more reddish than AR for an afternoon drive. Okay. Any other uh, point you think will be correct? Why do you feel that region C will be more reddish than A? Okay, everyone answer is wrong. See, you are telling E and D. E was saying region C will be more hotter in afternoon than region A. So in region A, we can already see that there is too much spelling, right? And wait a minute. Am I audible? Yes, okay. Hello. Understand what exactly these three lines are depicting. We are telling the red line will depict the more temperature, and blue line is depicting lesser sound area, more better area. So all the option region A, this region in midnight it will be more reddish, means it more delamination will be there in region A at the night time. Is correct, is wrong answer, right? This is clear. Second option is telling region B will be more bluish than region A for an afternoon drive. Region B, if you see the region B correctly, you will see that there is no delamination and not even some cracks are there. So it is a sound area. We can say it is a sound area, correct? And next is the region B will be more reddish than region A for a midnight drive. In midnight, there are chances that this area will be more used. People will avoid A area and C area. So there are chances that this area will be more used and it will be more reddish in the midnight time. In afternoon time, it will be not much used. Yes, guys, I think everyone is facing the issue with the audio because I'm also not able to hear you properly. So I will record the lecture and then record it again and then post it in the problem solving session. Fine. So next question is, a commercial reinforced concrete building is located near a flyover. Consider yourself as an engineer to protect it from the carbonation. Where do you think the carbonation front will be the highest? In the exterior column, interior column, beams, upper side of the roof, or upper surface of the sunshades? Where do you think the carbonation will be maximum? Your building is located near a flyover. You have to make sure of that. Mostly when we are telling that carbonation will be higher, it will be mostly in the interior side of the column. It won't be on the exterior side of column, right? Because it's located near a flyover, so that exterior part will be protected from sun, direct sun. And next is the underside of the roof. Same reason we can say. So your answer is correct, B and D, interior side of the column as well as interior side of the roof. In this place we can say that carbonation front will be higher. Okay, anybody have any issue with this question, or we will go to the next question? Question: the following photograph was taken during a visual inspection of a 25-year-old building. So inspect this picture properly, this part mostly, and choose the possible reason for the blistering or peeling of the paint on the wall. What can be the reason due to the for the peeling of the wall? B is the correct option, as we have bathroom at the back side. So because of stagnation of water in the bathroom, we will have this this peeling and blistering of the plaster mostly. B and D. B, stagnation of rainwater on ground. Okay, let's check the answer then. Answer is B only. See, if you can see properly, they have given some holes are here. So, and also the slope will be there. So we can't be sure that rainwater will be stagnated here. There is no proof to say that rainwater is stagnated here. So for now we will see, we can only like looking at this picture, we can only tell there is because of the bathroom there is a seepage, right? Okay, next question. Consider the design stage of a commercial reinforced concrete building to be located. I think this we have. Okay. Consider yourself as an engineer to protect it from the carbonation. We have already seen where the carbonation front will be more inside of the columns and underside of the roof. So next question that arises from that same question is, what? How would you recommend to increase its resistance against carbonation and prevent the corrosion due to the carbonation in future? Will you use SCM and more cover depth, or will you use SCM and better steel rather than TMT steel, mostly galvanized steel, or you will use anti-corrosion coating, or maintain the internal humidity of concrete element between 60 to 70 percentage of range, or by eliminating the rainwater and other source of water? What do you think you can adopt to prevent this type of corrosion? C and D. Actually, all the answers are correct. If you are using SCM, you are making sure that your concrete is less porous. So less the porosity of the concrete is, more chances that CO2 will not ingress into the concrete and will not cause carbonation induced corrosion. Secondly is, you are using larger cover depth. If you are using more cover depth, you are making sure that the carbonation front is not reaching till the steel surface. Okay, so first option is also correct. Second option is saying use of SCM and galvanized steel. You guys remember galvanized steel, Pope diagram of galvanized steel, right? It is like this. See, so galvanized steel is more stable at a pH of 9 to 11. So when we have a lower pH due to carbonation, the steel will be in passivation state, galvanized steel. So the use of galvanized steel in such cases will be a good strategy. Next is anti-corrosion, anti-carbonation coating. As you guys have already told, it can be correct. Next is the internal humidity. We have to element to be out of 60 to 70 days. It is out of 60 to 70 range, not inside 60 range. So it's also correct that if it is in between this range, more will be the carbonation. So it should be either less than this or more than this, right? If it's less than this, then we are making sure that there is no water available for carbonation. And if it is more than 70%, then we are saying that there is too much water that CO2 is not able to get inside the concrete. Last is, we are eliminating the rainwater and the other source of water. So if less water is available, there is less chance of carbonation. Is the question clear to everyone? During the inspection of a concrete bridge, you need to access the delamination in concrete at a dry, inaccessible and visible part of concrete. Which technique will you use? You have read many techniques, right? Rebound hammer test or UPV test, infrared thermography test. Which test do you think will be better in this case? Accessible area. So obviously we can't go and touch the concrete at that point. So it's the right answer. We will mostly use infrared thermography test in such cases. It's clear? So this is the last question for today. After the RCPT test, which additional test we can do to measure the depth of chloride penetration? There are no options. So what do you think? Which test we have to do to check how much chloride is penetrated through the concrete during RCPT? Chloride diffusion test. Chloride diffusion is correct answer, but the sample for our RCPT is very small, right? When we are doing chloride diffusion test, we are taking samples from small depths like 5 mm, 10 mm, 20 mm. It will be very difficult for us to do that on a very small specimen. So we will do a rapid test, as someone has said, silver nitrate test. So we will use silver nitrate test. That would be a easier method. What is done is we will spray the silver nitrate on the cutout specimen, and the part which is converted to white or silver, as we can see there, we can tell that that much chloride have diffused through the concrete in RCPT test. Is clear why we are not using chloride diffusion test? If anybody have any doubt, just raise your hand or tell or just type. Cutting for testing purposes. Also, how do we guarantee that the refill process does not compromise the structure integrity of the element? See, first you have to make sure that you are taking core from a point where you are actually seeing any damage, right? You'll take core from that point only. You should not take core from a good concreting. So when you are taking core and doing the testing, obviously whatever results you are getting, you have to repair that complete area, right? When you are repairing that complete area, then you will fill that complete area with the fresh concrete. In case you are not getting any kind of deterioration in there, and you want to just fill that core, then you should know what the parent concrete is made of, and you should make sure that your fresh concrete is almost similar to the parent concrete. It should not be much different than the parent concrete. And then there are some bonding agents which are used before concreting in such cases also. Some chemicals are used as a bonding agent, so we can use those bonding agents. And about structure integrity, I don't think a 100 diameter core will affect that much. We won't take a core till too much depth, so it won't compromise the integrity. But yeah, if to make sure, we have to use similar kind of concrete, and secondly, we should make sure that we are using the bonding agent. I hope it's clear, Uday, right? I hope we don't have any problem next week. Bye.